Hi class, welcome to Motor Learning and Performance, PEP 288 with me, Elizabeth Harding. I'm going to take you through online assessment number 5. So this was the assignment, right? And it's a little different than the assignments that I've given you before, so you're not required to do an online quiz. Rather, really what I'm hoping for is some beautiful tables and charts representing the data from this experiment on practice variability. So, and then there were 5 questions for you to answer as well on the template that I've posted to learn. And so let's just walk through the study really quickly. There were 2 different testing conditions, right? There was a constant practice condition and a variable practice condition. And the participants were set up such that they were a specified distance from the target during the practice trials. So in the constant practice group, they performed 25 trials of a beanbag toss, facing away from the target and tossing over their shoulder with their dominant hand, right, to this target here, which was a 1-by-1 target where they're in with lines every 5 centimeters. And so each one of these blocks, this -10, -9, actually represents a block of 5 centimeters. And so we look at here, we have 5, all the way up to 5 centimeters here, up to this 10. So we essentially had a 50 centimeter window here, and then of course a 5 centimeter target, and then another 50 centimeters on the other side. But this was just a way to categorize or to, I guess, keep it clean. So it's not necessarily a continuous variable. When we look at our data, you can't necessarily say that participants on average were 2 centimeters from 0, when in fact that 2 centimeters actually represents 10 centimeters. All right, but those are just semantics. We're just going to stick with this right here and get to the data. But the variable practice group completed 24 trials, but they completed 8 trials at 1.5 meters, another 8 trials at 2 meters, and then another 8 trials at 3 meters. And then after a break of about 10 minutes, both groups performed 8 transfer trials at a distance of 2.5 meters. And so important to note that neither practice group actually practiced from the distance that they were being tested on. And Schmidt's schema model tells us that variable practice, or the more you vary practice, the better your performance. And so we would expect to see the variable practice group actually perform better at that 2.5 meter distance, even though they had never performed it, than the constant practice group that really got very keyed in at tossing the beanbag from a 2 meter target. And of course, knowledge of results was given after every trial, practice trial. But then of course, no feedback whatsoever was given to the participants during the transfer trials. All right, so let's go ahead and take a look at the data, because down here, when I've asked you these questions, you're going to calculate the mean, absolute, and constant error for 6 blocks of 4 trials for the practice trials. And so basically, we're clumping those 24 trials, those 24 practice trials into blocks of 4. And that's to alleviate or average out any learning effect. And so let's go ahead and look at your data, because I understand that might be very confusing. So here's our data sheet here, and this represents the, I gave you 2 tabs. You had a variable practice condition and a constant practice condition. So for instance, in the variable practice condition, where we have 8 blocks of 1.5 meters, right, or looking over here, sorry, 8 blocks of 1.5 meters. We've basically averaged these first 4. So this would be like the very beginning 1.5 meter tosses, and then 5 through 8 would be, hopefully they're getting a little bit more practice. But again, we're averaging these blocks together. And so if you leave the raw data alone, you'll see that I've done this work for you. And we have absolute and constant error for trials 1 through 4 for this practice block 1. And then the absolute constant error for the next 4 trials 5 through 8 for practice block 2, and et cetera, and et cetera. So that left us with 6 blocks of practice and 2 blocks of transfer, right? So you're going to have to go ahead and calculate the average absolute and constant error for all of the practice blocks, in addition to all of the transfer blocks. And I'll show you how I did that using the constant practice sheet. So I've just gone ahead and made a little mean here just so I make sure I remember what everything is. So equals average, and then highlight the array that you want, and then just go ahead and carry that over. And then I don't really want to have a lot of extra data, so I'm just going to copy. So I'm Command C. I'm skipping these raw transfer trials here, the raw data from these transfer trials, and Command V. Okay, but you want to make sure if you were using, for instance, the copy, you just want to paste. Excel knows what column you're referring to, so you don't necessarily want to just paste the value because it'll paste in a negative 2.54, right? That would clearly be a mistake. Okay. All right, so there is your mean, absolute, and constant error for your constant practice group. So what I've done here is I've made another sheet. So I've just added a sheet and I named it table because I wanted to keep my table really clean. And I also wanted to make sure that anytime I messed or moved any of these variables around, that everything would update, including my table. So what I did was I referenced using just equals, and then I kind of cherry picked, hand picked back and forth to the sheet. So you can see right here, I have I've outlined it. First of all, I've labeled it absolute error so I wouldn't get confused. And then I added a header of practice blocks and then another header of transfer blocks. And then my two groups, my constant practice and my variable practice. And then here are my 6 blocks of practice. And so if you look right here, constant practice, absolute error 1, I have a value of 6.38, and you can see where it referenced. It referenced the constant practice sheet. Okay, that's in these half quotes right here, exclamation point AA18. And so if I go back here, constant practice, AA18 right here. Okay, and you can see 6.38. And so just kind of check, and then every other one is going to be absolute error. So 6.38, 6.02, 5.5. Okay, and then make sure that that looks 6.02, 5.5, make sure that that looks pretty reasonable. Okay. So just to clarify, so I want to look for constant error in the constant practice group, practice block 1. Okay, so constant practice, constant error. Here we go. So it's going to be, and then you couldn't, Excel wouldn't understand if you were to drag this across, and there is definitely an easier way to do this that would involve inserting columns and then eliminating the blank cells later, but I'm not going to do that. There's only, 12 practice block data points, so I'm just going to hand pick just to make sure I stay on target, but equals, and then go back to my constant practice group, looking for constant error, constant practice group, constant error, okay, and then the transfer trials. Okay, all right. All right, so I'll let you go ahead and do variable practice, the constant error for the variable practice group. So that would be this tab right here. Okay, just make sure that you stay on track. All right, and then quickly, just so that, well, just to set this up, because I wanted a label of my 6 practice trials and my transfer trials, just in case you don't remember, I just merged and centered these 6 columns or these 6 cells here. So I just highlighted, okay, just in case you never got that from a previous video. So you can undo, right? And then that only refers to this one cell here, right? But if you merge them together, it makes a nice header, right? And I just formatted, centered it up. All right, so now let's go ahead and look at your line graph. So really you are set up for success here. And all you need to do is just make sure you don't highlight anything extra. So I want to keep my headers and I want to keep my groups. So I'm just going to highlight here. Okay, and then insert. And I want a line chart. I want a pretty line chart with the dots. Okay. All right. So very important to make sure that you label your axes. So this is going to be absolute error. We want to get rid of this because it's ugly. Okay, so we're going to call this, and maybe not so many caps, absolute error. And I'm going to call this absolute error score. And the reason is because it wasn't precisely, if you look at this error here, let me go ahead and make this a little larger. Whoa, whoa, not what I wanted. Okay, that's better. Okay. Because these values here, now this represents the target, right? And I see, I don't love this either. So I would love to be able to format this, but I'm afraid I'm just going to get way too, just way too fussy, and it's just going to look terrible when I'm finished. See? I just really genuinely do not want a decimal in there, but yeah, it's just not going to let me do that. All right. Nope. Okay. Sorry, that's just, it's going to have to be that way. All right, so this 0 here is our target, so we have to leave it. So normally I would have you clean up this white space, just, because it's wasted space. But in this case, this really does tell our reader what's going on. But this, for instance, this 6 does not represent 6 centimeters, right? We'd have to multiply this by 5 because it was 6 blocks away from the target. So 30 or more, actually, it would be, because that 0 represented what? There was 2.5 centimeters on each side. Again, I'm getting very fussy. Sorry, it's late in the afternoon. But regardless, we don't want to necessarily call this centimeters. So what we would have to do in this case is make a caption for our table that explains that they were blocks of 5 centimeters, so that each one of those values here represents a block of 5 centimeters. Right, so I'll let you figure that out. At least those of you who watch the video will certainly have that inside knowledge, and a little bit of an advantage over those of you who don't watch the video. All right, that's it, right? We just need to copy and paste this and copy and paste this into the template, and most of the work is done. And now you just have to answer a few very simple questions. So let's look at those questions really quick. So this one, explain the terms transfer and retention as they pertain to motor learning. And so hopefully those terms, especially transfer, because we just discussed it as far as those 8 transfer trials. So how is that different or distinct from retention? And so in other experiments, we've talked about retention, right? And so basically, I just want you to define those 2 terms, and maybe for even just a little bit of extra, grade security, you might mention how they apply to some experiments that we've done in the past, right? Which group had the best performance on the transfer trials? So you're going to have to address both absolute error, so when direction didn't matter, and constant error when direction did matter, because they might be different, right? One group might have had better absolute error scores, and the other group might have had better constant error scores. And so this is basically just a reporting your results kind of question. And then tell me if the results from this experiment support Schmidt's schema model regarding variability of practice. And really, I want you to hone in on what happened to that variable practice group, right? And explain, did it fit the model? Did they do better than the constant practice group? You can even maybe suggest if you can kind of visualize yourself doing this experiment, what do you think would have been different as far as you and your learning being able to transfer to the last 8 trials. As far as directional error tendencies, so this is, again, looking specifically at the variable practice condition and during their practice. So did they have a tendency to undershoot or overshoot the target? And if there were, go ahead and describe those. So again, keep it very brief. They tended to overshoot the target. That's a beautiful statement. It's clean, it's to the point, and it gets the job done. So you don't have to get too wordy on that one. And then this right here, question 5, really reaching back to Gentile's taxonomy and that classification of motor skills. Give an example of how you would implement practice variability for a closed skill without inter-trial variability. So remember, closed skills tend to be our simplest skills. And then, of course, there's no inter-trial variability. So in the case where you're consistently tossing a beanbag, in a very still room, in a very still environment, at a target that doesn't change, right? That would be a closed scale with intertrial variability versus a closed scale with intertrial variability, where things are constantly changing, whether the environment is changing, whether the people around you are moving, whether the wind is blowing really hard from trial to trial, things like that. And then, of course, you'll discuss maybe how you could implement practice variability in an open skill. So I'm going to let you kind of look back to Gentile's taxonomy, if only because you're going to see it on your final, because it is a very valuable skill, especially when it comes to program design for patients and students and clients. Right, so I hope that gives you some security, and good luck with your assignment. Thanks.